Picture this, you wake up in London, you fancy lunch in New York City. Today, you board a sleek, futuristic jet. It climbs high, incredibly high above the Earth. The sky turns a deep indigo. You see the curve of our planet. Then, in less time than it takes to watch a blockbuster film, you are descending. New York, just like that. This isn't science fiction, not anymore. This is the promise of hypersonic travel. A journey from London to Sydney, Australia, currently a whole day of your life, could shrink. Imagine it. Under 4 hours. Think about what that means. The world as we know it is defined by distances. These distances shape our lives. Hypersonic flight is the next giant leap in this grand human adventure. So, what do we mean by hypersonic? It sounds fast and it is. Incredibly fast. To understand it, we need to talk about Mach numbers. You've probably heard of Mach 1. That's the speed of sound. It's about 767 miles per hour or 1,234 kilometers per hour at sea level. But the speed of sound changes with altitude and temperature. So, Mach 1 isn't a fixed speed, but a ratio. It's your speed relative to the speed of sound in the air around you. When an airplane flies faster than Mach 1, it's supersonic. Concorde was supersonic. It flew at about Mach 2, twice the speed of sound. Hypersonic flight takes this to a whole new level. Hypersonic speeds are generally defined as speeds greater than Mach 5. That's 5 times the speed of sound. Think about that. At Mach 5 you're traveling at over 3,800 miles per hour, or more than 6,100 kilometers per hour. That's fast enough to circle the Earth at the equator in just over 6 hours. Most commercial airplanes today cruise at around Mach 0.8. That's about 600 miles per hour. Hypersonic jets would leave them standing still. It's a completely different realm of flight. This realm of extreme speed opens up new challenges. To fly at hypersonic speeds, you need very special engines. Your typical jet engine, a turbofan, simply won't work. Turbofans have large spinning blades at the front. These blades suck in air and compress it. At hypersonic speeds, the air would hit these blades so fast they would tear themselves apart. So, engineers had to think differently. They needed engines with few or no moving parts capable of operating in extreme conditions. This led to the development of ramjets and scramjets. These are the powerhouses of hypersonic flight. First, let's talk about ramjets. A ramjet is a type of jet engine that uses the forward motion of the aircraft to compress incoming air. It doesn't need the complex compressor blades of a turbofan. Air rushes into the engine's inlet at high speed. The inlet is cleverly shaped to slow down and compress this air. Fuel is then injected into the compressed air and ignited. The hot, expanding gases then shoot out of the back, producing thrust. Ramjets work well at supersonic speeds, perhaps from Mach 3 up to Mach 6, but even they have their limits. For speeds beyond Mach 5 or Mach 6, we need something even more advanced: the scramjet. The SC in scramjet stands for Supersonic Combustion Ramjet. This is key. The most obvious impact of hypersonic travel will be on global connectivity. Journeys that currently take half a day or even longer could be reduced to mere hours. Imagine a business executive in London. They need to attend a crucial meeting in Singapore. Today, that's a flight of around 13 hours, plus travel to and from airports. It's a grueling trip, often requiring overnight stays and causing jet lag. With hypersonic travel, that journey could potentially shrink to just 3 or 4 hours. The executive could fly to Singapore, attend the meeting, and be back in London on the same day. This is a game changer. This incredible speed could revolutionize international business. Deals could be closed faster. Face-to-face collaborations could become more frequent, even across vast distances. The tyranny of distance that often hampers global trade could be significantly lessened. Urgent, high-value goods could also be transported across the globe with unprecedented speed. Think of emergency medical supplies, critical repair parts for industry, or time-sensitive documents. The ability to move people and goods this quickly could boost economic efficiency and foster new international partnerships. Section 5. A new era for tourism. Hypersonic holidays on the horizon. While business travel might be the first to embrace hypersonic speeds, imagine the future of tourism. What if you could genuinely consider a weekend trip from Europe to Australia, or a day trip from North America to Asia? Hypersonic travel could make such seemingly outlandish ideas a reality. The world's most remote and exotic destinations could suddenly become far more accessible. Think about visiting the Great Barrier Reef. the ancient city of Petra, or the temples of Kyoto, all within a much shorter travel time frame. This could open up entirely new possibilities for exploration and adventure. This new accessibility could transform the tourism industry. People with limited holiday time could venture further afield. The concept of a long-haul trip might change. Instead of spending 2 full days traveling to and from a distant location for a week's holiday, you might spend only a few hours in transit. This could make distant destinations more appealing to a wider range of travelers. It could also lead to the development of new tourist hotspots in previously hard-to-reach places. The map of global tourism could be redrawn. Our planet offers so much wonder. Would the experience of hypersonic travel itself become part of the attraction? Flying at the edge of space, seeing the curvature of the Earth, experiencing incredible speeds, these could be selling points in their own right. Some companies are even exploring concepts that blend high-speed transport with elements of space tourism. Imagine a flight that takes you high enough to experience a few minutes of weightlessness before arcing back down to your destination on another continent. Section 6. Shifting Power. The strategic implications of hypersonic technology. Beyond the realms of business and tourism, hypersonic technology carries profound strategic and military implications. The ability to deliver a payload, whether conventional or a sensor package, to any point on Earth in a matter of hours or even minutes, is a capability that nations will strive for. Hypersonic missiles, for example, are a major focus of development for military powers around the globe. These missiles are not just fast, they are also highly maneuverable. This makes them incredibly difficult to detect, track, and intercept with current defense systems. The development of hypersonic weapons could potentially shift the balance of global military power. Nations possessing these capabilities could gain a significant strategic advantage. This has led to concerns about a new arms race as countries compete to develop and deploy their own hypersonic systems, as well as defenses against them. The speed and unpredictability of these weapons could shorten decision-making times during a crisis. This could increase the risk of miscalculation and escalation. The stakes are incredibly high. It's a cosmic chess game with new fast pieces. Hypersonic technology also has applications in intelligence, surveillance, and reconnaissance. A hypersonic reconnaissance aircraft could gather vital information from deep within contested airspace with a much lower risk of being intercepted. It could provide rapid situational awareness during fast-moving events. The ability to quickly monitor vast areas of the globe would be invaluable for both military and civilian purposes such as disaster monitoring or treaty verification. Section 7. The hypersonic hurdles, challenges on the path to superspeed. While the dream of hypersonic travel is incredibly alluring, the path to making it a widespread reality is fraught with challenges. These are not small hurdles. They are significant obstacles that require brilliant minds and substantial investment to overcome. One of the biggest is cost. Developing hypersonic aircraft is extraordinarily expensive. The research, the materials, the testing, it all adds up. And the final ticket prices for passengers, at least initially, will reflect these high development and operational costs. Making it affordable for the average person is a long-term goal. Then there's the environmental impact. Flying at hypersonic speeds requires immense energy. Current designs rely on hydrocarbon fuels, which produce greenhouse gas emissions. The impact of a fleet of hypersonic jets on the upper atmosphere is also an area that needs careful study. We need to understand the potential effects on ozone depletion and climate change. Finding sustainable fuel sources or developing new propulsion methods that are more environmentally friendly is crucial if hypersonic travel is to be a responsible part of our future. Safety is, of course, paramount. Flying at Mach 5 or higher, at the edge of space, presents unique safety challenges. The extreme temperatures and pressures mean that materials must be incredibly robust. Section 8. Gazing into tomorrow, the dawn of widespread hypersonic reality. So when can we expect to be zipping around the globe at hypersonic speeds? What does the future hold in the next 10 to 20 years? It's important to be realistic. Widespread, affordable hypersonic passenger travel is likely still several decades away. However, we are on the cusp of seeing the first commercial applications emerge, albeit on a smaller, more exclusive scale. The progress being made is tangible. The dream is slowly but surely taking shape. The universe of possibilities is opening up. In the next 10 years, by 2035, we might see the first boutique hypersonic business jets become operational. These would likely carry a small number of passengers, perhaps 10 to 20 people, on key intercontinental routes. Think London to New York or Los Angeles to Tokyo. Tickets will be very expensive, catering to a niche market. We may also see more advanced hypersonic drones and uncrewed cargo vehicles. These could pioneer some of the routes and technologies before passenger services become more common. These will be the early whispers of a faster future. Looking further ahead, towards 2045, 20 years from now, the technology should mature significantly. We might see larger hypersonic aircraft, capable of carrying more passengers, perhaps around 50 to 100. Costs could begin to decrease, making it accessible to a broader segment of business travelers and perhaps some high-end leisure travelers. The network of hypersonic routes could expand, connecting more major cities across the globe. The challenges of environmental impact and safety will continue to be major drivers of innovation, hopefully leading to cleaner and safer designs. Our planet deserves responsible speed.